Scientists and space fans are getting worried about Pluto possibly running into Neptune. Big names like Neil deGrasse Tyson and Michio Kaku are talking about how bad things could get if that happened. So, how did Pluto get on a path that might cross with Neptune, and what would that mean for us on Earth? Pluto used to be called a regular planet, but now it's a dwarf planet because of its weird orbit. Still, people are fascinated by it. Recently, some experts said that Pluto and Neptune's orbits are getting too close. They're warning that they might hit each other, and that could be a problem for Earth. Pluto's trip around the Sun is pretty strange. It takes about 248 Earth years, and since we found it in 1930, it hasn't even made one full circle. What's really interesting is that Pluto's orbit isn't round like most planets, it's more like an oval. Plus, it's tilted at a steep angle compared to the other planets. One important thing is that Pluto's path crosses Neptune's. For about 20 years in each orbit, Pluto is actually closer to the Sun than Neptune. So, the question is, why haven't they crashed yet? Well, it's because of how gravity works with the other planets. People started studying Pluto's orbit soon after it was spotted, and it was a puzzle. Unlike most planets that orbit on the same plane, Pluto's is tilted and stretched out. It got even weirder when they realized Pluto's orbit crosses Neptune's. Even with all this, Pluto's orbit is pretty stable, which shows how complicated gravity is in space. The three-body problem is about figuring out how three big things, like Pluto, Neptune, and the Sun, move and affect each other with gravity. Things like asynchronous libration, nodal libration, and the VZK oscillation help explain this puzzle. Scientists say that asynchronous libration keeps Pluto and Neptune from hitting each other because they're always at least 90 degrees apart when their paths cross. Nodal libration also helps by making sure Pluto is way above or below Neptune's orbit when they get close. And the VZK oscillation explains why Pluto's orbit looks weird but stays steady over long stretches of time. Even though it might seem shaky, simulations from the late 1980s, edited to remove asterisk related to banned word, showed that Pluto's orbit is actually pretty predictable over billions of years. Better computer models have helped us understand how big planets like Jupiter, Saturn, and Neptune affect Pluto's path. The special thing is that for every 2 orbits Pluto makes, Neptune makes 3, which adds another layer of protection. Jupiter's strong gravity also helps keep things stable, and Saturn adds to the mix. These planets work together to keep Pluto on its path, making sure there's not too much chaos. These interactions are key to keeping things orderly in our solar system. Without them, things could get messy, with more planets crashing or getting thrown out of the system. Knowing about Pluto's orbit helps us understand how the solar system works. It shows that even orbits that look unstable can be balanced thanks to gravity and how things move in space. Keeping an eye on these things is important for learning more about our cosmic backyard. Looking closer at space often shows us how weird things can be, and Pluto's orbit is a good example. The idea of orbital chaos shows how much a planet's path depends on its speed and position. Even small changes can mess up Pluto's path in the long run. Computer models have been a big help in understanding Pluto's motion. By playing around with the simulations, scientists can see how small changes can lead to big differences in where Pluto goes. Studies from the 1980s, edited to remove asterisk related to banned word, showed that Pluto's orbit is reliable because of things like asynchronous and nodal vibration, but it can still be unpredictable. Even a tiny change in Pluto's starting point or speed can send it on a totally different path over millions of years. Still, Pluto's path stays pretty steady over billions of years, which means there's some kind of order underneath all the chaos. When it comes to guessing what will happen to planets with weird orbits like Pluto, it's hard to make long-term predictions. Good models can help scientists guess where they'll go, but there's a limit to what we can know for sure. These models depend on exact starting data and being able to copy complicated interactions. Even a small mistake can lead to very different guesses, which makes things tough. The chaotic nature of orbits like Pluto's reminds us that the universe is always changing. We've learned a lot about how things move in space, but Pluto's case shows how much more there is to know. The huge distances between stars and planets mean that crashes are rare, and planets that don't belong to any star are unusual. So, crashes between planets are very unlikely. Studying how the gas giants affect Pluto's orbit helps us understand how the solar system works as a whole. Each planet's weight and location changes how the other planets move in small ways. But even with all these complicated gravity things, some scientists still worry about Pluto and Neptune hitting each other. So, why are people getting worried now, even though there are so many stable things? Neil deGrasse Tyson, a famous astrophysicist, has some interesting thoughts about Pluto. He famously said it should be called a dwarf planet instead of a regular one. He points out that we're always learning more about how things move in space. For him, Pluto's change in status isn't a bad thing, it just shows that we're learning and changing how we classify things. He thinks Pluto's complicated orbit is a sign of how much we still have to learn. He thinks these mysteries are what make space so exciting. Tyson also knows that big space events get people excited about astronomy. He sees things like Pluto's orbit and its reclassification as a chance to get people interested and teach them about space. By pointing out the dramatic and weird parts of how things move in space, Tyson hopes to get more people interested in space science. Tyson is still warning people about the dangers of Pluto's unpredictable movement. After doing a lot of research, he's worried that the three-body problem could be a real danger, leading to a crash with Neptune. He says that could mess up the balance of the solar system and cause problems that could even affect Earth. A crash like that would be huge, sending out tons of energy and possibly breaking Pluto apart because it's small and icy. The pieces could spread through the solar system, causing problems for other planets. For Neptune, the crash could even change its orbit or atmosphere. Michio Kaku, a well-known theoretical physicist, also has some interesting ideas about this. Kaku links the study of how planets move to bigger questions in physics. He sees Pluto's orbit as a glimpse into the future of space travel and thinks that understanding how planets like Pluto and Neptune affect each other is important for planning future missions. Learning this stuff could help us travel through the outer solar system and avoid dangers. Kaku also points out that what we learn from Pluto's orbit can be used to study other things in space, giving us a way to understand and explore distant places. When talking about planets, Kaku often talks about the link between how things move in space and theoretical physics. He thinks that complicated interactions like the one between Pluto and Neptune show the universe's basic laws. Kaku's research, especially in string theory, tries to explain these laws. He suggests that studying planetary orbits, especially weird ones like Pluto's, can reveal deeper truths about how things are put together. Like Tyson, Kaku has also thought about what would happen if Pluto and Neptune crashed. From his point of view, it would be a big event in astronomy and could help advance string theory. String theory says that particles aren't points but tiny vibrating strings and tries to connect all the forces and matter in the universe. A big crash in the outer solar system could create extreme gravity and energy, giving us a chance to see how matter and forces act under those conditions. The gravitational waves from the crash could give us data to test theories about gravity and spacetime, edited to remove asterisk related to ban word. Even though Earth probably wouldn't be affected physically because it's so far away, the scientific effects of such a cosmic event could be big, helping us understand basic forces and matter. Pluto's orbit is a good example of how things move in space, showing both stability and chaos. Its unique path, affected by the gravity of big planets like Neptune, shows how complicated space is. The universe has tons of mysteries, and the three-body problem is just one of them. Other possible disasters are on scientists' minds. While planetary crashes are unlikely, they're not impossible. The three-body problem shows how planetary orbits are changed by different forces, especially gravity. In crowded systems like TRAPPIST-1, which has 7 Earth-sized planets, gravity can cause orbits to resonate over time. These resonances could mess up orbits and lead to crashes. Even though TRAPPIST-1 is stable now, astronomers are watching its planets to study how closely spaced things interact, especially under gravity. This research helps us understand how orbits change. Rogue planets, which drift through space after being thrown out of their star systems, add another layer of unpredictability. These planets can travel huge distances and might end up far from where they started. As they wander, there's a small chance they could run into other star systems. If a rogue planet enters a new solar system, there's a tiny chance it could hit one of that system's planets. But because space is so empty, the chances of that happening are very small. With better computers, we know more about how big planets like Jupiter, Saturn, and Neptune change Pluto's path. Pluto and Neptune have a special connection. For every 2 trips Pluto makes around the Sun, Neptune makes 3. That helps keep them from hitting each other. Jupiter's huge gravity helps, too, and even Saturn plays a part. These planets keep Pluto's path safe. Without them, things in the solar system would get crazy, and planets might start crashing into each other or getting thrown out of the system. Understanding Pluto's orbit helps us see how everything in the solar system works together. It shows us that even orbits that look unstable can be safe because of gravity. It's important to keep watching and studying these things so we can learn even more about space. Space is full of surprises, and Pluto's orbit is a great example. Orbital chaos means that even a small change in speed or position can totally change where a planet ends up. Scientists use computers to see how these changes affect Pluto's path. Studies from the 80s showed that even though things like asynchronous and nodal vibration help keep Pluto steady, its orbit can still act up. A tiny change at the start could send it on a completely new path over millions of years. But even with all that, Pluto's path stays pretty much the same over billions of years. That means there's some kind of order to its wild ride around the Sun. It's hard to guess what will happen to planets like Pluto way in the future. Scientists use computers to make educated guesses, but they can only do so much. The smallest mistake in the starting info can throw everything off. The fact that Pluto's orbit is so chaotic reminds us that the universe is always changing. We've learned a lot about how planets move, but Pluto shows us there's still so much we don't know. Planets don't hit each other very often because space is so huge. And planets that don't orbit stars are rare. So, the chances of 2 planets smashing into each other are super low. Looking at how the big planets change Pluto's orbit helps us understand the solar system better. Each planet changes the others in small ways. Even with all these things keeping Pluto steady, some scientists still worry about a Pluto-Neptune crash. Why? Neil deGrasse Tyson, the famous scientist, has some thoughts. He's the one who said Pluto wasn't a planet anymore. He thinks our understanding of how planets move is always growing. To him, Pluto's change in status isn't a bad thing. It just shows that we're learning new things about space all the time. Tyson thinks Pluto's crazy orbit is a sign of how much we still have to that space exploring is so exciting discover. He also knows that big space events get people excited about science. He uses these events to get people thinking and learning about space. Tyson still tells people to be careful about Pluto's crazy movements. He's worried that the gravity of the 3 bodies involved, Sun, Pluto, Neptune, might cause a crash. He says that could mess up the solar system and even affect Earth. If Pluto and Neptune hit, it would be huge. It would make a lot of energy and might even break Pluto apart because it's small and made of ice. The broken pieces could fly all over the solar system and be dangerous to other planets. Depending on how they hit, it could even change Neptune's orbit or the way it looks. Michio Kaku, who studies string theory, also has some ideas about all this. He sees Pluto's orbit as a way to peek into the future of space travel. He thinks understanding how planets like Pluto and Neptune affect each other could help us plan missions to far-off places. Kaku says that what we learn from Pluto can help us study other things in space, too. He thinks that how planets move and gravity are linked to the basic laws of the universe. His work tries to explain these things. He says that studying orbits like Pluto's can help us learn more about how the universe works. Like Tyson, Kaku has also thought about what would happen if Pluto and Neptune crashed. He thinks it would be a big thing for scientists and might even help prove string theory. String theory says that everything is made of tiny, vibrating strings. A big crash in space could create extreme gravity and energy, which would give scientists a chance to see how things act under those conditions. The waves from the crash could also give us info to test string theory. Even though Earth would probably be safe because it's so far away, the crash would have a big impact on science. It could help us understand the basic forces and matter in the universe. Pluto's orbit shows us that the solar system is both steady and chaotic. Its strange path, changed by the gravity of the big planets, especially Neptune, shows how complex space is. The universe is full of unknowns, and the dance between three heavenly bodies is just one of them. It is just one among many other possible disasters loom in the minds of scientists. While planets don't collide often, it's not impossible. The way gravity changes planets' orbits is the three-body issue. That could be the issue in the future. TRAPPIST-1, which has 7 Earth-sized planets, gravity can produce rhythmic oscillations that may destabilize the orbits, eventually leading to planetary collision. Even though TRAPPIST-1 is pretty, don't be fooled by its prettiness. Astronomers are vigilantly tracking its planets to study how closely spaced celestial bodies interact, especially under gravitational stress. This research broadens our understanding of orbital evolution. Rogue planets drift aimlessly through space, having been ejected from their star systems due to gravitational upheaval or stellar intrusion. As they wander, there's a really remote chance that they could encounter and intersect with other star systems. If a rogue planet enters a new solar system, there is a minute possibility it could collide with one of that system's planets. Because the distance between stars and planets is so vast, there is not a worry.